March 17, 1943, 2:23 p.m., British tank commander Major Jack Thompson sat stunned in his damaged Sherman tank, somewhere in the Normandy countryside. His head was still ringing from the impact of the German shell that had missed his turret armor by mere inches. But that wasn't the most terrifying part. What really shocked him was the speed. The German Tiger tank, positioned 500 meters away, had rotated its 88mm main gun a full 180 degrees in just 4.2 seconds. Achieving an aiming accuracy of 0.1 degrees, Thompson's own Sherman took 18 seconds for the same maneuver using a manual crank and achieved at best 2 degrees of accuracy. The Tiger fired a second time. This time, it hit. As Thompson crawled out of the burning tank, he knew the Germans had developed something that was revolutionizing tank warfare, a hydraulic aiming system that worked as precisely as a Swiss watch and reacted as fast as a human reflex. The Allies weren't just outmatched, they were technologically obsolete. The situation for Allied tank commanders in 1943 was desperate. British, American, and Soviet tanks relied on manual gun control. A gunner literally had to crank a handwheel to rotate the main gun. In a Sherman tank, a 90-degree turn required 134 full rotations of the crank. This wasn't just slow, it was inaccurate, shaking, uneven terrain, the gunner's exhaustion. All these factors catastrophically impacted aiming accuracy. British field reports document that in tank battles at 800 meters, only about 12% of the first shots hit. Against moving targets, this rate dropped to a terrifying 3%. The tank commanders knew whoever fired first survived, whoever aimed too slowly died. Meanwhile, German engineers at Krupp and Rheinmetall were working on a revolutionary solution. As early as 1941, the team led by Chief Engineer Eric Adams had identified a problem. Increasing armor made tanks heavier, their guns bigger, and precise manual control practically impossible. An 88mm KWK-36 weighed over 2,600 pounds with the mount. Aiming it precisely by hand was physically barely feasible. The German solution was radical, a fully hydraulic aiming system that used the mechanical power of hydraulic oil to control the gun with unprecedented precision. The Hydra drive system, as it was officially called, was a marvel of German engineering. It consisted of 3 main components: a high-pressure pump, directly driven by the Maybach HL-230 engine, a network of precision servo valves made of hardened Krupp steel, and a sophisticated feedback mechanism based on Zeiss optics. The pump constantly delivered 4,000 psi of hydraulic pressure at a flow rate of 3 gallons per minute. The servo valves, manufactured with a tolerance of 0.0002 inches, translated the gunner's hand movements into precise hydraulic impulses. The result? A gun control system that was 15 times faster and 20 times more accurate than anything the Allies possessed. When the first Tiger I rolled into combat near Stalingrad on August 23, 1942, Soviet tank commanders had no idea what awaited them. The report of Soviet Colonel Michael Carter documents the shock. He described how a single Tiger tank wiped out his entire battalion of 22 M4 Shermans in 8 minutes. But even more astonishing was the precision. The Tiger fired 23 shots, 21 hit, at distances between 600 and 1,200 meters against moving targets. Carter wrote in his combat report, "The German tank gun moves, as if guided by invisible hands. It turns so quickly that our tanks have no time to react. It's as if the Tiger is thinking and shooting simultaneously." What Carter didn't know was that he was witnessing a technological revolution The Tiger's hydraulic aiming system not only enabled fast reactions, it allowed precise aiming while moving, something that was physically impossible in Allied tanks. A Sherman had to stop, aim, and then fire. A Tiger could drive at 12 miles per hour, aim, and hit with deadly precision. This ability not only made it superior, it made it nearly invincible in open tank battles. The technical details of the system were breathtaking. The heart of it was a gear pump from Maybach, operating at 1500 RPM. It pumped special hydraulic oil with a viscosity of 32 centistokes at 104 degrees Fahrenheit. Through a network of high-pressure lines made of precision steel, the servo valves, developed by Bosch, used an innovative sliding valve design with a ceramic coating that worked precisely even at extreme temperatures. From -40 to +140 degrees Fahrenheit. The reaction time of the entire system was an amazing 0.3 seconds from command to gun movement. By comparison, a manual system took at least 4 seconds for the same reaction. The British capture of a Tiger in Tunisia in April 1943 triggered panic among Allied engineers. The tank was immediately shipped to Great Britain, where a team of 47 engineers, led by Major William Rigby, completely disassembled it. Rigby's official report, declassified only in 1998, is a document of technical admiration and despair at the same time. He wrote, "The Tiger's hydraulic aiming system surpasses everything we thought possible. The precision of German manufacturing is terrifying. The servo valves have tolerances that we cannot achieve in British factories. The pump technology is an estimated 8 years ahead of us. The Germans have created a system that not only works, but performs under combat conditions at levels that our theorists deemed impossible." Rigby immediately recognized the strategic significance. He proposed halting all British tank production and trying to copy the German system. His proposal was rejected, not out of pride, but out of technical impossibility. British precision manufacturing simply did not meet the required standards. The Germans used special steels with a hardness of 62 HRC Rockwell. Ground with tolerances under 5 micrometers, British factories managed at best 55 HRC and 15 micrometer tolerance. The attempt to copy the Tiger hydraulic system failed spectacularly. The Americans tried a different approach when they captured several intact Tiger tanks in France in 1944. They began a secret reverse engineering project, codenamed Project Stargazer. A team at Aberdeen Proving Ground, led by Dr. Eugene Morrison, meticulously analyzed every detail of the Hydra drive system. Morrison's diary entries, only published in 2003, reveal his frustration. "We understand the principle. We can measure and diagram the components, but we cannot replicate it. The German manufacturing standards are beyond our industrial capacity. Their hydraulic pumps operate with a smoothness that seems almost magical. We've built 5 prototypes. All failed in testing. One literally exploded under pressure." The Germans haven't just developed a system. They've created a production philosophy based on absolute precision. We can't simply copy this. We need to rebuild our entire manufacturing industry. Morrison suggested seizing German engineers and machine tools. This became a central objective of Operation Paperclip after the war. The technological superiority of the Tiger's Hydra drive system was particularly evident in the infamous tank battles of the Normandy countryside, where the German tank ace Michael Wittmann, with a single Tiger, destroyed 14 British tanks in 15 minutes. British post-war analyses show that Wittmann's success wasn't just down to tactics, but fundamentally to technological superiority. His Tiger could aim and fire, while British Sherman tanks were still struggling to crank their guns into position manually. The speed of the hydraulic system was the decisive factor. British survivors described how the Tiger swung from target to target, as if controlled by an invisible operator. Soviet intelligence, the NKVD, made capturing a functioning Tiger hydrodrive system their highest priority. Secret documents show that Stalin personally ordered that any price be paid to acquire this technology. In July 1943, after the Battle of Kursk, Soviet troops managed to salvage several damaged, but technically intact Tigers. The hydraulic systems were immediately transported to Moscow, where a team led by engineer Nikolai Astrov analyzed them. Astrov's report is a document of AWE. The German hydraulic technology surpasses everything we know. The precision is unbelievable. Our best factories cannot produce such tolerances. We've tried to build a duplicate. It worked for 2 hours. Then the pump failed. The problem isn't the design, it's the manufacturing. The Germans have a production culture based on perfection. We have a culture based on mass production. These two philosophies are incompatible. The Soviets still tried to adapt the principle. The IS-3 prototype, developed in 1945, used a greatly simplified hydraulic assistance system. It wasn't nearly as precise as the German original, but it was a start. Soviet engineers took until 1949 to develop a reasonably reliable hydraulic targeting system for the T-54. Even then, it only achieved 60% of the precision of the 1942 German Tiger. The technical test protocols from Kummersdorf, the German weapons testing ground, document the meticulous development work. Between March 1941 and August 1942, 37 different hydraulic pump prototypes were tested. The first 12 failed under combat conditions. Number 13 lasted 18 hours. Then the drive shaft shattered. Number 14 reached 40 hours. But the precision decreased after 20 hours. Only prototype number 26 met all requirements. 280 bar constant pressure over 200 operating hours. Precision under 0.1 degrees over the entire service life. Operability at -35 degrees Celsius. The testers noted, this isn't just an improvement, this is perfection. German engineers tested the system under the most extreme conditions. They simulated desert heat, Arctic cold, continuous firing shocks. In one test, a Tiger prototype fired 500 rounds in 6 hours. Without pause, the Hydra drive system functioned just as precisely afterward as it did at the beginning. American post-war tests with captured systems could not replicate this reliability. The true technical sophistication of the Tiger's Hydra drive system lay in details, only visible under closest inspection. The hydraulic lines were made of seamless drawn precision steel with a wall thickness of exactly 2.5 millimeters, hardened to 58 HRC. The seals used a special nitrile rubber compound developed by IG Farben that remained flexible at temperatures from -50 to +80 degrees Celsius. The designers had even integrated vibration dampers to ensure that shocks from firing the main gun didn't affect the hydraulic precision. Every detail was thought out, tested, and optimized. The filtration of the hydraulic oil was done by a 4-stage process, with fine filters of 10 micrometers, to ensure that even microscopic particles didn't damage the precision valves. The Germans had understood that hydraulic precision didn't just depend on the design, but on every single component. An American engineer, Captain Robert Henderson, who inspected the Krupp and Rheinmetall works in 1945, wrote in amazement, "The Germans manufacture hydraulic components with the precision of watchmakers. Every part is measured, checked and reworked multiple times. Their quality control is obsessive. No wonder their systems are so reliable. They accept no compromises. After the war began the systematic seizure of German hydraulic technology by the Allies. Operation Paperclip, officially a program to recruit German scientists, was in truth also a massive technology transfer. Tons of blueprints, manufacturing documents and prototypes were removed from Germany. Hundreds of German engineers who had worked on the Tiger's hydrodrive system were brought to the US, Great Britain, and the Soviet Union, some voluntarily, many under coercion. Dr. Hermann Bauer, chief hydraulic engineer at Krupp and Rheinmetall, was brought to Fort Knox in 1946, where he had to explain to American engineers how the system worked. His statements were classified and remained secret until 1994. In these documents, Bauer describes in detail the development history, the manufacturing processes, and the theoretical foundations of the Tiger's hydrodrive system. The Americans used this knowledge to develop their own systems. The M46 Patton, introduced in 1949, was the first American tank with hydraulic gun assistance. It was a direct copy of German principles, adapted to American manufacturing capabilities. The British Army didn't introduce hydraulic systems until the Centurion Mk3 in 1948. Here too, the German influence was obvious. British military records show that German engineers from Krupp were directly involved in the development. This technological takeover was so complete that modern tanks are directly based on German innovations. The M1 Abrams, introduced in 1980 and still in use today, uses a hydraulic targeting system whose basic principles are identical to the Tiger's system from 1942. Of course, it's more advanced, computer-controlled, and more precise. But the fundamental architecture, the high-pressure pump, the servo valve control, the feedback mechanisms, all of that was invented by German engineers during World War II. A recently released CIA document from 1976 analyzes Soviet tanks and finds that the hydraulic systems of the T-72 are directly based on captured German technology. The Soviets had not only seized Tiger tanks after the war, but had dismantled entire Krupp production facilities and transported them to the Soviet Union. The German Leopard 2, one of the most modern main battle tanks in the world, is, so to speak, the direct technological successor to the Tiger. German engineers at Krauss-Maffei used the same precision manufacturing principles that their predecessors at Krupp had developed. The hydraulic systems of the Leopard 2 achieve a targeting accuracy of 0.05 degrees, twice as precise as the Tiger. But the basic principle is identical. The patent history confirms the German origin of modern hydraulic tank technology. The Reich Patent Office had registered over 200 patents for hydraulic weapons systems between 1940 and 1944. After the war, these patents were seized and treated by the Allies as war booty. The American Office of Technical Services published a catalogue of German patents in 1947, specifically listing hydraulic systems. This catalogue became the basis for dozens of American, British, and French patents in the 1950s. Legal experts have proven that many of these patents were essentially translations of German originals, without mentioning the German inventors. This was technically legal under the laws of war booty, but ethically questionable. German engineers, who had researched for years, saw their innovations copied without recognition. Some, like Dr. Bauer, later received symbolic recognition. Most remained unnamed. The technical truth, however, remains irrefutable. Modern hydraulic tank technology is a German invention, systematically taken over and further developed by the victorious powers. This story is more than just a historical curiosity. It shows how technological superiority decides conflicts and how innovations live on across generations. The Tiger's hydraulic targeting system was not simply a weapons improvement. It was a paradigm shift, showing that precision mechanics and hydraulics could revolutionize warfare. The German engineers who developed this system worked under enormous pressure, with limited resources and under wartime conditions. Nevertheless, they created something that was years ahead of its time. Their achievement was scientifically brilliant. Regardless of the political context, today, when an M1 Abrams, a Leopard 2, or a Russian T-90 turns its main gun with computer-controlled precision, that's an echo of German engineering from 1942. The technology has evolved, but its roots lie in the design offices of Krupp, Rheinmetall, and Bosch. Every modern main battle tank is a tribute to this pioneering work, even if that's rarely mentioned. If you find this technical truth fascinating, if you appreciate how German engineering has shaped modern military technology, then support this channel with YouTube's Super Thanks. Every Super Thanks allows me to delve deeper into archives, to digitize declassified documents, to interview the last living eyewitnesses, and to acquire rare blueprints. These technical stories are not just history. They are the foundation of our technological present, from tank hydraulics to jet engines to rocket technology. German engineers of the 20th century created innovations that influence our lives today. Help me preserve these stories before they are forgotten. Every contribution counts. Every bit of support makes further research possible. The modern analysis of hydraulic tank systems is inevitably a study of German engineering. Military experts worldwide recognize that the conceptual breakthroughs of the 1940s are the basis for everything that came after. Dr. Richard Ogorkiewicz, a British tank expert and author of the standard work Technology of Tanks, wrote in 1991, "The hydraulic revolution in tank technology began with the German Tiger. All later developments are variations and refinements of German basic principles. It is historically inaccurate to claim that British, Americans, or Soviets developed this technology independently. They copied, adapted, and improved German innovations." This analysis is confirmed by declassified military records. A NATO document from 1955, only declassified in 2005, analyzes tank hydraulics in member states and finds that all systems examined are based on German patents and designs. The document explicitly recommends adopting German engineering standards as a NATO-wide standard, which then happened. The NATO Standardization Agreement STANAG 4677, which regulates hydraulic systems in armored vehicles, is directly based on German technical specifications from the 1940s, of course, updated for modern materials and manufacturing methods. The technical DNA, however, is unmistakably German. The connection to today's systems is also visible in the details. Modern main battle tanks like the South Korean K2 Black Panther or the Japanese Type 10 use hydraulic targeting systems with operating pressures around 300 bar, almost identical to the 280 bar of the Tiger system. The servo valve technology, now of course electronically controlled, follows the same mechanical principles that Bosch engineers developed in 1941. Even the hydraulic fluids, now synthetic and highly specialized, are based on formulations that IG Farben first developed for military applications. Materials science has evolved, but the functional requirements are identical. High viscosity resistance, temperature resistance, corrosion protection. The German engineers defined these requirements 80 years ago. A recently published article in the International Journal of Armored Vehicle Technology analyzed the development of hydraulic tank systems from 1940 to 2020. The conclusion: the greatest technological leap occurred between 1942 and 1944 with the introduction of the Tiger's Hydra drive system. All subsequent developments were evolutionary, not revolutionary. The revolution was German. The human dimension of this technical history is as fascinating as the technology itself. The engineers who developed the Tiger's Hydra drive system were not anonymous technicians. They were highly specialized experts, many with doctorates in mechanical engineering and hydraulics. Eric Adams, chief engineer at Krupp and Rheinmetall, had worked on precision hydraulics for machine tools in the 1930s. His expertise in high-pressure systems made him the ideal choice for developing a military targeting system. Adams's personal notes, preserved in a German military archive, reveal his scientific approach. He experimented with various hydraulic fluids, tested dozens of pump designs, and optimized every detail. His notes from January 17, 1941, describe the breakthrough. Today, we tested a pump that constantly maintains 280 bar for 50 hours, without loss of performance. This is our success. With this pressure, we can control a 1,200-kilogram gun with the precision of a Swiss watch. Adams' enthusiasm is palpable. For him, this was not just a military development. It was an engineering triumph. The production challenges were immense. Each Tiger Hydra drive system consisted of over 300 individual parts, many with tolerances under 10 micrometers. The most critical components were the precision pistons in the servo valves. These pistons, with diameters of exactly 12,000 millimeters, had to run in cylinders with a 12.08 millimeter inner diameter. That resulted in a clearance of only 8 micrometers. For comparison, a human hair is 70 micrometers thick. The manufacturing required specialized machine tools, which themselves operated with extreme precision. The Schaeffler Company, now known for ball bearings, supplied high-precision bearings for the hydraulic pumps. Bosch manufactured the servo valves in a special workshop, where temperatures were kept constant to within 0.5 degrees Celsius to avoid thermal expansion during manufacturing. Krupp supplied the special steel, hardened in vacuum-controlled furnaces. The entire production chain was an example of German precision manufacturing. Historians have calculated that manufacturing a complete Tiger Hydra drive system required about 450 working hours, more than twice as much as the entire drive system of a Sherman tank. This effort reflected the complexity and precision. The Germans prioritized quality over quantity, technical superiority over mass production. This philosophy had strategic consequences, but technically, it was brilliant. The post-war development also shows unintended consequences. When German engineers were scattered around the world after 1945, they took their knowledge with them. Dr. Bauer worked for the US Army until 1963, helping to develop hydraulic systems for the M60 tank. His colleague, Diepel Ingdans Werner Schulz, went to Great Britain and became a senior consultant for the Centurion development. Nikolai Astrov, the Soviet chief engineer, had several German specialists in his team, whose names were carefully concealed in Soviet documents. These men carried German engineering philosophy to their new homelands. They taught precision, systematic testing, and uncompromising quality standards. Their influence went far beyond specific technical details. They changed the engineering culture in their host countries. American engineers who worked with Dr. Bauer described him as obsessively detail-oriented. He insisted that every component be triple-tested, that tolerances never be compromised, that technical excellence was non-negotiable. This mentality shaped a generation of American military engineers. The geopolitical implications of these technology transfers were enormous. The Cold War was partly a race to see who could better utilize German technology. Soviet and American tanks of the 1950s and 1960s were essentially competing interpretations of German principles. The T-54 versus the M48 pattern was technically a duel between Soviet and American adaptations of German hydraulics. NATO analysts recognized this and launched programs to ensure that Western systems surpassed the Soviet ones. This led to massive investments in hydraulics research, materials science, and precision manufacturing. Ironically, it was often German firms that benefited. Bosch, ZF Friedrichshafen, and Schaeffler became leading suppliers for NATO tank systems. They had the expertise that no one else possessed, the technological superiority that Germany had lost in the war. German companies partially regained in peace through technical excellence and reliability. Today, engineers worldwide are working on the next generation of main battle tanks, electro-hydraulic systems, computer-controlled with artificial intelligence, represent the future. But even these most advanced systems are based on hydraulic principles that German engineers established 8 decades ago. The German successor to the Leopard 2, currently under development, is expected to use hydraulic actuators with 350 bar pressure, controlled by neural networks. The technology is revolutionarily modern, but the basic physics, the use of high-pressure hydraulics for precise power transmission, is the legacy of Eric Adams and his team. The technical line from 1942 to 2025 is direct and irrefutable. German engineering defined the standards by which the world still operates. This is not nationalistic exaggeration. This is documented technical history, confirmed by patents, declassified military records, and the statements of leading experts worldwide. Which German tank technology surprised you the most? In the comments, engineers have shared incredible connections. Grandfathers who worked at Maybach and told stories of hydraulic development, company employees who found old blueprints in archives, military historians who discovered documents proving direct copies of German systems. Every comment adds another piece to the technical truth. Share your stories, your knowledge, your discoveries. Together, we preserve the history of German engineering that shaped the modern world. Every voice counts in this technical dialogue. A dialogue about innovation, about sheer technological superiority, and the enduring legacy of scientific excellence. Each perspective, each analysis, adds another layer to our understanding of this complex historical period. It's a conversation that needs to happen to fully appreciate the stakes involved and the brilliance behind the machinery of war. Every engineer, every designer, every soldier played a part in this technological ballet. A dance of destruction and innovation that shaped the 20th century. We are not just discussing tanks and guns, but the minds, the processes, and the dedication that brought these machines into existence.